Here we're going to look at an introduction to set theory, where we examine some of the terms, definitions, and symbols that will be important to us as we study sets. To begin with, a set is a collection of objects that we will call elements. So we're going to say that a set is a collection of elements. The most common way for us to represent a set is going to be in what's known as roster form, where we list out those elements in something that looks like this. We have the set 1, 2, 3, 4. You'll notice those squiggly lines that I've just made there. Those are called braces. We are not going to use parentheses, and we're not going to use brackets. We're not going to use parentheses. We're not going to use brackets. When we list a set in roster form, we are going to use braces. As you can see, the ones I've drawn here are far from perfect. Yours don't have to be perfect either. Just make sure you're using braces, not parentheses, and not brackets. If you're looking to type those on your computer, they're next to the letter P. So that's where you can find braces. Another way that's common for us to represent a set is by using a capital letter. We might say A equals the set 1, 2, 3, 4. And now we can either list the set in roster form, 1, 2, 3, 4, or we can just use the capital letter A to represent this set. Now let's look at some symbols that'll be important for us. The first of those kind of looks like an E, and it looks like that, and it means is an element of. For example, we could say that 2 is an element of the set 1, 2, 3, 4. We could also say that 2 is an element of the set A. Either of those would be true statements. If something is not an element, then we use that same symbol with a slash through it. For example, 7 is not an element of set A. That would be a true statement. That's how we use is an element of and is not an element of. Another symbol that's going to be important for us is a symbol you're probably pretty familiar with, and it's the symbol for equals. And for two sets to be equal, they must contain the exact same elements. Let's take a look at set 1, 2, 3, 4, and the set 3, 1, 2, 4. Now the elements aren't written in the same order, but would these two sets be considered equal? Well, they do contain the exact same elements, so yes, they are equal because they contain the exact same elements. Now, how about set 1, 2, 3, 4, and set A, sorry about that, let's fix that up a little bit, A, B, C, D. Those two sets do not contain the exact same elements, so they are not equal, but they sure do have something in common. They each contain 4 elements, and if two sets contain the same number of elements, then they are equivalent. So while the two sets we've just been given, 1, 2, 3, 4, and A, B, C, D, are not equal, they do contain the same number of elements, so they are equivalent. One thing I want you to notice here, if two sets are equal and they contain the exact same elements, then they must also be equivalent. The last thing I want to mention here is a symbol that you may have seen before, and it looks like that. It's something that you may have used to represent no solution in an algebra course, and what this symbol represents is what's known as the null set or the empty set. And what that is it's a set that contains no elements. That's a little bit hard to wrap your head around at first, but it's just a set that doesn't have anything in it. For example, the set of purebred Chihuahuas that weigh over 150 pounds. Well, there wouldn't be any of those, so that set wouldn't contain any elements, so it would be the empty set or the null set. The reason that's used in algebra sometimes is you're looking for the solution set, and that solution set doesn't contain any elements. There is no solution, so that's why that symbol is used in algebra sometimes. One distinction I want to make here is if we have a set that has a 0 in it, that does have an element inside. So that is not the same as the empty set or the null set. That's just a set that has 0 as an element. That is not the same as the null set that doesn't contain any elements. So make sure you don't confuse those two. This set does contain an element, so it's not the empty set. This set over here that contains no elements, that's the empty set, also known as the null set.